Hello friends, welcome to my YouTube channel. In today's video, we will be discussing about chamfers and fillet. So I have decided to make two videos on this topic. So this is the first part of the video, and in this we'll be discussing about how to dimension a chamfer and a fillet and a little exposure to its application and benefit. However, the second video which I will be making, it will be more specific to the benefits of chamfer and fillet, and I will give some specific examples as well. So let's start this video. So here you see a dowel pin, and it is having some feature on the right edge, and this feature is called a chamfer. It's basically a cut. And the second part is a step shaft. Here also you see a round kind of a feature in the center, and that is called a fillet. So let's cover, let's see chamfer first in detail. So here you are seeing a dowel pin, and the it's basically a cylindrical part, and here you are seeing a cut on the right edge. So when we want to define this cut on the right edge, you need two dimensions. So here the chamfer which we are talking about, it's a 45-degree chamfer, and the cut, basically the leg length C, is equal because it's a 45-degree chamfer. So now it is not necessary for a chamfer to have a 45 degree. It can be less as well. I have designed one component uh, for a hydraulic application where a plug has to go inside one hole, and that hole was having one seal. So when I was assembling the plug into that hole, because of the seal I was facing so much resistance. So I have given like 20 to 30 degree of chamfer on the plug so that it slides inside it. So there is no restriction on the angle, but it depends upon the application. So here in this video we are specifically talking about the chamfer which is having equal leg length and an angle of 45 degree. So now when you want to dimension this, the question which comes to your mind is, what should be the value of C? So you can use one formula which will help you to determine the value of C, and that formula is this one. C is equal to 0.1 times under root D, where D is the diameter of the cylindrical part. Now when you use this formula, you will get some value of C which might not be a standard value, and it is always recommended to use a standard value, and for that I am giving you some values which are standard. So these are the standard values of C, which so it is always recommended to use a standard value because the tools for making these features will be easily available and the cost of manufacturing will be less. But if you go with some non-standard value, then the manufacturer might need to procure some standard tool, and the cost might go up. So whenever you use the formula which I am showing on the screen, the value which you come up with, uh, you uh, may match that value with the standard value of C and use that standard value. So let's see, let's understand it with a with one example. So here when you see, let's say the diameter of the shaft is 50 mm. So when you use the formula, you will get a value as 0.707 mm. Now this is not a standard value. So you see in this table that 0.707 mm lies between zero point 0.8 and 1, and you are free to use any value between it, but when you round off this value, the closest value is zero point 0.8. So I decided to use a chamfer dimension of zero point 0.8. So this is very easy and good way to dimension a chamfer with 45-degree angle, and this is what I use when I design any part and where chamfer is needed. Now uh, one note, uh, like if the surfaces are non-contacting surfaces, then you might need to give a chamfer of zero point 0.1 to zero point 0.2 mm. Now for non-contacting surfaces, you may not need to specify chamfer dimension specifically. uh, the best option is to put a note which says remove all sharp edges. So that is what it means. So this is how you can dimension a chamfer and a fillet. Now one point is like chamfer is usually given on the external corners and fillets are given on the internal corners, but there are exception to these rules as well. So it can come on the external and on the internal edges, but most of the time you will see a chamfer on the external corners. So now let's move on to fillets. So here you are seeing a step shaft, and in a step shaft this particular feature which comes between the uh, two junction of the shaft is called a fillet, sometimes it's called round. So now to decide the dimension of this round or this fillet, uh, you may need to use the formulas to calculate the stresses which are inducing in this shaft, and you need to consider the stress concentration factors to see whether the shaft will be able to take that load or not. So you use a table something like this. So I got this image from Google. So here KT is the stress concentration factor, which depends upon the radius diameter of the step shaft and the round radius. So you need to see with what R value and what diameter of the shaft values your component is able to take the load, and based upon that you decide the values of fillet over here. Now the main challenge which comes is something which comes and assembles in this region. What should be the dimension or how it needs to be designed? So that is what we'll be seeing in the next slide. So here you see this red part is a step shaft, and I have shown a component which comes assembles in this region, and in you can have three different type of features in this particular region where the fillet is coming, and I will show you how you need to control the dimensions in that particular area. So when you see the first image, you can either give a round on the mating part, a fillet on the mating part, and the fillet dimension of the mating part should be 1.2 times the fillet radius of the stepped shaft. So if you dimension like this, uh, it is there you wouldn't see any interference between the radius of these two parts, and it fits well. Similarly, in the second example, you see there is a cutout in the component which comes and assembles into this step shaft, and the cutout dimensions are S is equal to 1.2 R. So this is what we should be following. And in the third example, we have provided a chamfer with 45-degree angle and equal leg length. So here also the leg length should be 1.25 times the 1.25 times R, and where R is the fillet radius of the stepped shaft. So this is uh, this is a very easy and simple way of dimensioning the chamfers and fillet. And if you have any questions or any examples you want me to show, you can put in the comment section. And this is the way we should chamfer and we should dimension a chamfer and a fillet. Now before I end this video, I want to show you why do we want to give chamfers and fillet. So I will not be discussing in details, but as I mentioned in the beginning of the video, that there will be a second video which will be talking more about the benefits with a specific example, so that will be covered, but here just wanted to give you a brief idea. So basically chamfers and fillets are provided to protect the hands from injury and to protect precision surface from chance damage. So while handling the components now with your hand, sometimes if it is having sharp edges, your skin might get damaged. So to prevent that, and to facilitate assembly, to facilitate press fitting, to prevent metal from rising around whole edge, this happens during the press fitting, and the chamfer and fillet helps reducing it, and it helps to reduce the edge pressure, It helps in eliminating load concentration at the edges, and it improves the appearance of the component. And the next item is related with the heat treatment. So chamfers and fillet are used to prevent edges from overheating and decarbonizing, and it also reduces the stresses, quenching stresses at transition. Another point is related with the casting, and chamfers and fillet ensures uniform solidification of metal and cooling, and it also reduces the shrinkage stresses. Uh, the next one is to increase static and cyclic strength at transition, and also it enhances the durability of cutting edges. Now these are some of the benefits or the purpose of chamfers and fillet I have mentioned, but there are a lot more, and which I will be covering in my next video with specific examples. So don't forget to subscribe my channel, and if you like it, hit the like button, share it, hit the bell icon so that you will not miss the notification of my next upload. And if you have any doubts or question or anything which you want me to cover specifically in the next video, do write